In this section, we want to take a look at how to solve exponential and log equations. And the first thing we'll look at is how to use the one-to-one property of exponential functions to solve exponential equations, which means exactly the same thing as what I wrote there, but I like the consistency. So let's start by considering the equation 4x squared is equal to 4x. If we want to solve this, we need to find the value for x, or values for x if there's more than one solution, that makes that true. We know that 4 squared is equal to 16, which means the expression on the right also has to be equal to 16. The only way that can happen is if x equals 2, because 4 squared would be 16, so our solution would be x equals 2. This gets us into the one-to-one property of exponential functions, which tells us for any value b raised to the s power, if that's set equal to another value b raised to the t power, then those two equations can only be true whenever the two exponents are equal to each other, which is what we saw in that previous example we were considering. 2 is equal to x, those two exponents had to be equal to each other. This property is true as long as our base b is not equal to 1. We'll use this in examples 1, 2, and 3. For instance, in example 1, both exponential expressions are base 4. So since those bases are the same, in order for these two expressions to be equal, we must have the exponents equal to each other. So that's going to be true only if negative 9x to the minus 1 power is equal to 4x. From there, we can solve by adding 9x to both sides. Which will give us minus 1 is equal to 13x. And then dividing both sides by 13 will give us a solution of x is equal to negative 1 over 13. Since the bases were the same, the exponents have to be equal in order for the two expressions to be equal, so we set those equal to each other and solved. Sometimes our expressions aren't written exactly in that format, but we can look at manipulating them a little bit to try to get them in that format. For instance, in example 2, before we solve, we could divide both sides by 4, which would have this become 2 to the 3x power is equal to 8 over 4, or just 2, which is the same thing as 2 to the first power. Now that the bases are the same, in order for those expressions to be equal, we set the exponents equal to each other and solve. Dividing both sides by 3 gives us x is equal to 1/3. In example 3, again, we need to manipulate this given expression, this given equation, before we can solve it. In order to do that, we're going to rewrite everything in terms of this same base 2. For instance, we could write 1/4 as 1 over 2 squared times 2 to the 5x is equal to 8, we can rewrite as 2 cubed raised to the x minus 4 power. On the left, we can combine those two base 2 expressions by subtracting the exponents. So 2 to the 5x over 2 squared will be the same thing as 2 to the 5x minus 2. And then on the right-hand side, we have a power raised to a power, so we can multiply those expressions together. So we'll take 3 times x minus 4 to get 3x minus 12. Now that everything's written in terms of the same base, we can set those two exponents equal to each other and solve from there. To do that, we can subtract 3x from both sides and add 2 to both sides. which will give us 2x is equal to negative 10. And then dividing both sides by 2 will give us x is equal to negative 5.